point, you should already be familiar with the concept of differentiation through the temporal differentiation and also with the concept of sparsity in space. Now, we will apply spatial differentiation. In particular, we will compare pixels across different locations. So we can compare pixels in different horizontal locations, and we can compare pixels in different vertical locations. So horizontal differentiation will give us this kind of pattern. You can see that we see unique patterns in the image. In contrast, when we take vertical differentiation, we see slightly different patterns and different objects that appear. How would you describe this change? What can you observe? Please discuss with your TA and with your group. So now you have the exercise to apply spatial differentiation and vertical differentiation as well as horizontal differentiation. So diff x is across the horizontal axis and diff y is across the vertical axis. And here we just need to call the plotting function. Importantly, there is a difference between temporal and spatial filters. If you remember from our temporal case, beyond just one-step differentiation, there is an advantage of taking a box filter. So when we focus on the temporal case, we add this kind of temporal filter where we add a peak here with some deviation here. In contrast, for the spatial filter, since space don't have any priority for a specific direction, in contrast to time, we would like to make our filter symmetric. In particular, when you think about time, there is some difference between past and future, so we would like to consider only past time points. In contrast, when we think about spatial filtering, we would like to consider both the left and the right side, or both the upper and the lower side. So we want to make sure that we give the same weights to different sides, and that's why we make our filter symmetric. So here, you need to define the spatial filter, and you can take inspiration from how we define the temporal filter. So after you create the spatial filter, you should observe this kind of structure where you see that we get symmetric filter overall. Now we can play or change the length of the spatial filter to get different patterns. So when we convolve with different sizes of the filter, you can see that we can reveal different sparsity patterns. So, lastly, you need to call the spatial differentiation filter that you created here in order to find the sparsity across the vertical axis. So you can see that here, I already defined for you how to apply sparsity horizontally. Now you need to call the same function for vertical differentiation. So good luck!